Hello everyone, welcome to today's webinar, Simplify Power with µModule Regulators, brought to you by Excelpoint Systems. My name is Travis Heng, your moderator for today. Before we begin today's session, I would like to cover a few housekeeping items. Throughout the webinar, please feel free to ask questions. You may click the chat icon at the bottom of your screen and type your questions in the chat box. We will answer your questions at the end of the webinar, and if we do not have time to answer all the questions, or if we need a longer answer, we will send the answer to you in an email. If you want to watch the webinar again after today, the recording of the webinar will be hosted on our company's website. You will receive an email with the link to access the archive after today's session. At the end of the session, please feel free to take part in a quiz and survey where you stand a chance to win an Amazon gift card worth $100. Your feedback will help us to improve future sessions. Last but not least, we will announce the winners of our previous webinar, Analog Devices M-Sure, before we conclude today's webinar. Now, let me introduce our speaker for today. Alex Lim is Field Application Manager of Excelpoint Systems. He has 14 years of experience in power and mixed-signal electronics. His role now is leading the Analog Devices Field Application Engineering team for ASEAN and ANZ regions. Prior to Excelpoint, Alex worked in several semiconductor manufacturing companies covering Asia-Pacific region. Without further ado, let's start today's webinar. Over to you, Alex.
Thank you, Travis. So now I'm Alex Lim. Let me start with my presentation today, Simplify Power with µModule Regulator. So first of all, what is power µModule? As you can see here, this is a simple illustration what µModule is. µModule actually is a solution that covers your power switches, DC-DC controller, your capacitor, resistor, diode, magnetic, and your compensation circuitry into one thermally enhanced BGA and LGA package. So with this µModule, it can help you to provide a high performance in a smaller footprint. So let's look at the comparison between the conventional switching controller, µModule regulator, and switching regulator. First of all, let's look at the schematic. As you can see for the schematic here, µModule regulator, the schematic is very simple with a minimum component count. As you compare to the switching controller, there is a lot of passive component and active component outside, and the schematic design will be much more compressed. And because of this complexity, you will need a lot of time to design your schematic, and for your PCB layout, it's very compressed and there are a lot of considerations for you to consider. But compared to the µModule here, you can see that the design effort is as simple as you designing a LDO regulator. Then let's say we compare to the switching regulator, the output power of µModule can be much higher. As so far, you can even support up to 100 ampere per channel for a µModule regulator. But switching regulator, the output power is much lower. Let's look at some comparison for the PCB area. So as you can see from here, this is an illustration of the PCB area needed for a 2-channel 2.5 ampere output requirement. So you can see that in the past when you use a switching regulator, LTC3633, the PCB area needed here is very big because of the use of inductor outside, capacitor, everything outside. But you can see here with the technology advancement now, when we are using an LTM4622 µModule solution, there is only about 3 passive components outside, and the area needed is very much smaller and minimum. Again, here is another example. This example is if you need about 4 ampere 4-channel for your system. So you may use LTC3605 in the past, then you would need 4 pieces of game in order to deliver 4 channel 4 ampere output. So you can see here the area needed is about 900 square millimeter, but with the technology advancement now, when you choose we can offer you 4 LKM4644, which is a 4 channel 4 ampere µModule. The area needed is as small as 240 square millimeter square. So the income of the PCB area reduction is about up to 73%, which is very significant. And the area that you save, you can use it for others usage. And maybe I can check with you how many of you are from the industry that you have a lot of high mix low volume application. So mostly I believe that you are facing some issue with your inventory and cost, because for your design, when you use a lot of different parts, you are not able to accumulate them for a higher volume for negotiating a better price with your supplier, and your inventory management will become very difficult. So especially when you need a short lead time. But now, don't need to worry anymore. With the use of µModule, we can offer you a flexible configuration. Okay, for example, when you use LKM4644, 4 channel 4 ampere µModule, you can configure it into 4 channel output, 3 channel output, 2 channel output, and single output, supporting out to 16 ampere for the system. So with this, you can make it like a common part. So make your design become simple, and you can accumulate this part much easier with a higher volume to negotiate a better price for your design. And also, when maybe during your design, you may need a certain increase in output power, you can easily just combine one more output channel to deliver a higher current to your system. It makes your design much more flexible and error-proof. And also, with the technology now, the power system become much more complex. So most of the time, I believe that you will face the issue with your power sequencing and margining. So maybe some of you have already encountered this sequencing and margining problem previously. You will know that it is so difficult. Every time you will change the power sequencing and margining, you may need to redesign your whole PCB schematic and layout. It makes your design need much longer time. Your development time become much longer, and you need to re-verify it every time. But now, AGI, we are able to offer you a digital power system management. So how this DPSM can help you? This DPSM can control and monitor the switching regulator through a PM buses, SM buses, or I2C bus interface. So what this thing can do is, it allows you to control and monitor some functions. For example, like allow you to monitor your output voltage, controlling your power sequencing, adjusting your power margin, and also allow you to monitor your current and temperature. And with this, it will also allow you to enable the use of fault log. So the main benefit that this thing can bring to you is it's very easy to design, because we have a LK Power Play GUI that you can utilize it to simulate the system. Then you can visualize the effect, and this can make your design become much more easy. Not only this, it also increases your system reliability. Why is it so? Because you can now having a much more tightly controlled voltage accuracy, allow you to have a remote debugging, fault reporting and logging, and you can respond to the fault much more quicker. And also, µModule is a solution that can offer you a higher scalability. So for example, here you can see from here, this is an illustration. For example, we have LKM4650 µModule, which can deliver 50 ampere per channel. So when on this board itself, we have about 7 pieces can deliver up to 350 ampere. You can see that when we combine the number of output together, the current sharing is very linear, and this allows you to connect them in parallel for deliver higher current. And also with this, the efficiency you can see from here is very much optimized, yeah, and very good for your system. And let's look at the package technology that µModule use. All µModule come with LGA or BGA package. So with this package is the smaller package ever that we can offer, because this is almost similar to the wafer size. But now with the technology advancement, we can offer you an ultra thin package with the height of about 1.82 mm or 1.91 mm. So you can see this is the very low profile that ultra thin package can offer to you. So what is the main benefit for this ultra thin package? You can see here in the past, due to the profile of the µModule, we cannot put it on the bottom side of the PCB, and this would occupy some space on the top side of your PCB. But now with this ultra thin package, we can put the µModule on the bottom side of your PCB, and the space saved on the top side can be used for other purpose. So it can help you to reduce your PCB area and to make your system become much more complex. Not only this, it can make your thermal management become much simpler by sharing the same heatsink with your microprocessor as shown here. For example, like this is the microprocessor and this is the ultra thin package µModule. They can share the same heatsink. Not only this, some of the µModule they come with integrated heatsink. As shown here, there are some examples of them. So with this integrated heatsink, it allows you to have a faster heat dissipation and more efficient heat removal from the IC. And there are some µModule come with a component on package also COP. So with this, the inductor on top can serve as a heatsink also, make your heat dissipation become much more efficient. So with the advanced package, it can actually help you to have a better cooling for your system. So with a better cooling, your power density can be increased, and it can allow you to have a higher current per channel for your µModule to be delivered. Not only this, with the advanced package, we allow you to have a top side cooling, and some of the µModule even you can use an inductor as your heatsink, and also allow you to have a better flexibility for your heatsink usage. You can also share it with your microprocessor as shown here. And most of our µModule come with it comply with EMC standard. As you can see from here, there are some parts are certified. You can find their standard compliance certification online. So why we can deliver this low EMI? Because µModule come with this silent switches technology. So you can see from here, this is a conventional switching regulator. There is a hot loop here and here. Because of this hot loop, the EMI can be affected significantly. But now with AGI patterns, we are able to come out a true hot loop as shown here. Because the true hot loop, they can cancel the magnetic field generated by the hot loop, and the EMI can be further reduced. And this is the new innovation. And besides that, the assembly also being improved. As you can see from here, no longer using the bonding wire, but we are using the feed chip. So with this difference, you can see here the EMI is much lower. And now we also have a new silent switches cool technology. In the past, for the first generation of silent switches, you need to be very careful about the placement of your input capacitor. They must be in line. So, but for micro-giant switches Q topology, these Q capacitors are integrated into the IC itself. So you make your PCB design will become much more simple, and the linking will become smaller, and this allows you to have a faster switching and better load transient performance. So now you can see here is an illustration of what is inside a micromodule. So you can see here this is the controller, inductor, and some passive component. With this giant switches Q technology, it can allow you to have a higher integration with a much better EMI performance. So the next slide, we will be showing you some animation video about these giant switches. And you can see that this here show you some of the parts come with this giant switches technology for the micromodule. It have the part cover out to support out to 125 degrees for commercial and industrial application, and out to 150 degrees for automotive applications. Okay, so and also we understand that most of you use an FPGA and microprocessor for your design. So for ADI, they also partner with a lot of these famous FPGA provider and microprocessor provider. So for example, like Altera, Xilinx, and NSP. So if you do use this kind of FPGA and processor, please feel free to look for us, and we can advise you the reference solution that have been proven and tested and verified power management solution based on your FPGA and processor need. And all of these micromodules come with a very high reliability. So you can see from here, these are some of the testing conditions that micromodule have been conducted to confirm the high reliability. For example, like power cycle, operating life, mounting temperature, temperature packing, temperature cycle, and thermal shock. So the ultimate target is to have a zero failure, and so far the FIT lab is below 0.4, which is very, very impressive. And micromodule actually do not only cover about power, it also offers a very wide portfolio. For example, like battery charger, set down, buck boost, buck, LED driver, current sourcing, and it also comes with some unique features like isolated, digital power management, ultra-thin, ultra-low noise, and multiple output, and even inverting output. So we have a lot of portfolio to offer for your applications. So the target application will be like aerospace and defense, communications, data center, healthcare, industrial automation, instrumentation, and management. So if you have any inquiry, please feel free to contact to Excelpoint. Our FAE will be very happy to support you, to advise you which are the micromodule that suitable for application. So this comes to the end of my presentation. Thank you. So if you do have some question, you can let us know. Yeah.
Thank you, Alex. Now we have come to the end of our presentation, and we would like to move on to the Q&A session. As a reminder, please click the chat icon at the bottom of your screen and type the questions in the chat box on the right. If we cannot answer all your questions today, we will come back to you after the webinar. Okay, let's see what questions do we have for today. Okay, we have one question from the floor. The first question, Alex, how many micro-modules can the user connect in cascade parallel?
Okay, for the number of output that can be connected in parallel, actually this depends. But what I can advise is before your design, we can use the LK spike and also the design tool LK power cap to do a simulation, then we can confirm the result. Yeah.
Okay, thank you, Alex. We have another question. The second question is, what are the target applications of analog devices micro-modules?
Okay, as mentioned just now, for the target applications will be aerospace and defense, communication, data center, healthcare, industrial automations, instrumentations, and measurement. Those applications are the recommended applications for these micro-module applications. Yeah.
Okay, thanks. Let's see. One more question is, what are the other packages available besides BGA and LGA package?
So far, we only offer two packages, LGA and BGA. There is no others package will be offered because of these two packages are the best package for this micro-module, and they can offer the smallest possible solution size. Yeah.
Okay, thanks. Let me scroll down a bit. Okay, one more question. Besides regulator, are there any other offerings for micro-modules?
Yes, also as mentioned just now, besides regulator, actually micro-module also come in power, battery charger, LED driver, current source, and also there are some unit micro-module also, like DAQ micro-module also. So you can find out more information from AGI website.
Okay, thanks. We have one question. Maybe I can take this question. The gentleman asked, is it possible to name a few real use cases in Asia with end user name? I would say this information is confidential. It's actually not so appropriate for us to name the customer names. But in terms of the applications, I believe Alex has already mentioned in his presentation and also in the Q&A session. So, but we can actually discuss more offline if you would like to know more about this information. Okay. Okay, so I guess we'll take one more last question from the floor due to time constraint. Are there any battery management systems using micro-module?
There is no battery management system using micro-module, but we do have the battery charger. Yeah, battery charger. Yeah, okay. So there are difference. Yeah.
Okay. By the way, if there's anyone who is interested in the BMS system, BMS solution for analog devices, please also feel free to come to us for further discussion. Okay, Alex, I think that's all for the Q&A session due to time constraint. Thank you. So before we end the webinar, let's move on to the quiz and feedback session. So over here on the screen, you can see that there's a QR code here. Please use your smartphone to scan the QR code and help us to provide feedback on the webinar. Your inputs will be very useful for us to improve our future session. Not to mention, you also stand a chance to win an Amazon gift card worth $100. So we'll leave the screen there for a few seconds for you to scan, and please take some time to give us your feedback. Okay, so we are coming to the end of the session, but before we end, I would like to make two announcements. First is to announce the winners of our MSure webinar. So this webinar was actually held on the 27th of May, and if you have missed this webinar, you may actually go to our company website to access this online archive. So these are the two winners that have won the $100 Amazon gift card. So the first one is Eric Lee. Second one is Tan Li Wei. So congratulations to both winners of our MSure webinar. Okay, another announcement that I would like to make is on our virtual trade show titled Smart ConnecTech Asia 2020. So this event will be held on the 9th and 10th of September. During these events, there will be new product solutions as well as demonstrations conducted online for you. So please access our company website to get more details. Okay, I guess it's time to conclude for today, and thank you for your time to attend this webinar, as well as thank you Alex Lim for the presentation. So until next time, thank you and see you soon.